Are you guys about ready to be done with math for the week? That's good, because we're almost there. We only have one new math lesson, and that takes place today. Tomorrow we're going to have a test review, and so then we'll be done with the week, and of course the review is not going to be any new information. So let's close out strongly what it is that we've already started so well, and we're going to do that with section 7 of chapter 11, and that's going to be on cube roots. Now, cube roots are very similar to square roots, but to understand what a square root is, you first have to know what a square is. And let me give you an example. If I were to have 3 squared, and this isn't associated with the problems up here, but I'll erase it, but just as an example, if I were to have 3 squared, what is 3 squared? Remember, it's not 3 times 2, which is 6, it's 3 times 3, or 3 times itself, 3 to the second power, which is 9. Okay? Now, if I were to try to find the square root of 9, what is the square root of 9? It's some number that times itself gets you the number 9, which is the number 3. And it takes us back in terms of the number itself. I know the power is different up here, but it takes us back to originally where we started in terms of the number itself. And so that's the relationship between a square root and a square. Now, a cube root, guys, is very, very similar to a square root. But if you can imagine, to understand what a cube root is, you first need to know what a cube is. And so I hope you can see okay. I think you can. But I'm going to state these, even if you can't see them perfectly. Remember, I'm working with a fairly small board. But 2 to the third power is a cube. A cube is any term that is to the third power. So 2 cubed, or 2 to the third power, guys, once again, is not 2 times 3, which would be 6, but it's 2 times 2 times 2. In other words, it's the number times itself, including the first time it appears. It'll be a total of 3 times it appears, and times itself an additional 2 times. And so 2 times 2 times 2 is 2 to the third power. In other words, 3 2's multiplied times each other. 2 times 2 is 4, and 4 times 2 is 8. So the cube of 2 is 8. Well, what do you think the cube root is? Guys, if I were to try to find the cube root of 8, and if you'll notice, it's the same symbol, okay, the same symbol as a square root, but the difference is, can you see that? There's a 3 that's written at the top of that line, and between the start of what looks like the division sign right there, there's a 3 that's written right there, which means not the square root, but the cube root. In other words, the cube root is what number times itself gets you to the number that is known as the radicand, or the number underneath the square root sign or symbol. And by the way, I've written in here, it's pretty small, just in case you can't see it, the number that's written in here to tell you that it's the cube root. By the way, we're not doing this, but you can go as high as you want to. You can do the 4th, the 5th, the 6th, and so on in there. If there's no number that appears, it's understood 2, or the square root. But if you have a number like a 3 written in, the 3 tells you it's the cube root. And regardless of what that number is that's written in there, that's called the index. Okay, that could be significant somewhere along the way. Write that down in your notes. That number is the index. But the number found underneath the square root sign or symbol is the term that we've been using a lot in this chapter. It is the radicand. Anyway, point being this, what's the cube root, not the square root, but what's the cube root of 8? In other words, what number times itself again, which we haven't done yet, gets you to 8, and that is the number 2, because 2 times 2 times 2 is 8. It's not 6. 2 times 2 is 4, and 4 times 2 is 8. Okay, does that make decent sense? Well, over here on, as you're looking at it, it'll be the right side, correct? Yeah, the right side of the board. That's always hard. For me, it's the left as I'm pointing. But on your right side of the board here, Notice the square root of when the negative sign is in the radicand itself is underneath the square root symbol. There are 0 real roots. Remember that? And the reason for that is, and that's a review as far as that. The square root of a negative number is no solution, meaning there's no number times itself that's going to give you a negative answer. Because if it's positive and you multiply a positive by a positive, it'll be positive. If it's a negative and you have to multiply that number by itself, 2 negatives are going to make a positive, so it can never be negative. So it has 0 real roots. Now on the other hand, notice if you have that 3 symbol in there, meaning you're taking the cube root and not the square root, and it's of, say, a number like 64, there is 1 real root of that. And the reason for that is you can have a negative number times a negative number times a negative number. And remember, because it's an odd number, this goes way back earlier in the year, when you have an odd number of negatives multiplied times each other, you will end up with a negative. Okay, but if you have an even number like 2 times the square root multiplying 2 negative numbers, then you're never going to end up with a negative number because 2 negatives always make a positive. But 3 negatives multiplied times each other will always be a negative, so there's 1 real root. Now, over here, top right, if you're taking, notice that 3 is not there, so it's understood just the square root of 64. There will be 2 real roots if you're taking the square root of a positive number. And the reason for that is, remember, it can be plus or minus. So when you apply that square root, it can always be plus or it can always be minus, because both are always going to end up with a positive number underneath, and that's why. Now, if you take the cube root of 64, there's only going to be 1 real root, because it can only be a positive number times a positive number times a positive number that gives you a positive number. Over here, it can only be a negative times a negative times a negative that would get you a negative number if it's the same number multiplied by itself 3 times. Okay. So, I hope that adds up. Again, I know this is a new concept, but let's not just talk about it. Let's more so put it into practice, and I think it'll make more sense. Look at 1a. Find the cube root of 100. And notice that 3 in there means find the cube root, not the square root. Find the cube root of 125, meaning what number times itself will get you to the number 125. Okay, well look at what it ends. That's a helpful hint. It ends in the number 5. So you know that 5 has to be a factor of it. And watch this. This one's pretty simple. What if I were to take 5 times 5 times 5? Now that's not 15, right? It's not 5 plus 5 plus 5. 5 times 5 times 5 times 5. What is 5 times 5? 5 times 5 is 25. And you multiply that times another 5, okay? If you have 4 25s, that's 100, and then we still have 1 left over. What's 1 more 25 over 100? That's 125, okay? So, if I multiply 5 times 5 times 5, that gets me 125. Guys, what's the cube root? What's the cube root of 125? It is the number 5. And that's my answer. Because in finding the cube root, I ask myself, what number times itself, times itself, times itself gets me to that radicand of 125? And that is the number 5. Guys, I didn't mention, but I'm just fine with you using your calculator in some of these. Now, again, there's some of them to get the right answer, you're not going to be able to find the totality of the answer using your calculator, but use it to help you some. And I want to give you an example. What's the cube 1b? What's the cube root of 216? Okay, guys, that's a ridiculous number. What's the cube root of 216? Where am I? There we go. I can kind of see it now. So what I'm going to do is I'm going to take 4 times 4 times 4. That's 64. No, it can't be that, can it? And if you'll look as a hint, I'm just giving you an example here. But if you look at a hint at 1b, 125, the cube root of that's 5. Well, 216, even though it's a negative, is a larger number with a negative. Technically, it's smaller, but I think you catch my drift. Okay, so I'm going to put in a number larger than 5, because obviously it has to be larger than that. And what I'm going to do is multiply 6 times 6 times 6. Ooh, that's a bad number in the Bible, isn't it? 666. But I'm going to do it mathematically, okay? 6 times 6 times 6. Look at that. That's 216. Okay? Well, I'm trying to find not a positive 216. I just did it in a shorter, easier way on my calculator. I'm trying to find a negative 216. If I take negative 6 times negative 6 times negative 6, because I have an odd number of negatives multiplied times each other, the negatives are going to win out. If it's an even number of negatives, the positive sign wins out. But it's negative when you have an odd number, no matter if it's 357 or 3,575. Okay, you still have an odd number and it's going to be negative. But negative 6 times negative 6 times negative 6, we just found is negative, we're just adding the negative signs all, is negative 216. So guys, what number, when I ask what's the cube root of negative 216, it's what number times itself times itself times itself gets me to the number negative 216. And that number, as we found, is negative 6. And so that's the simple answer to it. Now, if we weren't using calculators, I will admit to you, it'd be a lot harder, but if you haven't already, break out your calculator, guys, and use it. I don't mind. But again, like our square roots, we're going to get to some numbers that when you have to, because you can't break it down any further, leave it in square root form. Don't try to take the shortcut to the calculator, because I don't think you guys, any of you, have a calculator that's going to get you where you need to be to get the right answer. Even though technically it would be correct, in proper form, if it can't go down any further, is to leave it in I'm saying square root, but cube root form, just like in square root. Okay, number 2, A. Find between which integers these numbers lie. How about the cube root of 70? Okay, the cube root of 70. What I need to do is to figure out some perfect cubes. That's a good place for me to start. How about, hey, we did one just a minute ago. Do you remember when we punched in 4? 4 cubed, 4 times 4 times 4. Do you recall what that is? That is 64. 4 times 4 times 4. Okay, and that's from what we did on the calculator a moment ago that you saw. Okay, well, what's the one, and that's the number 4. So what would the next one be up from there? We did that one a minute ago. 5. What is 5 cubed? 5 times 5 times 5 is 125. And so we could take the cube root of 125, and look, it's hard when you've been doing square root, isn't it? Do you notice how I left that off? When you're doing cube roots, don't do that. I know it's easy, and I even just did it accidentally. Remember, if you aren't making mistakes, you're doing nothing, all right? But when you're making mistakes, you're moving somewhere, you're accomplishing something. So the reason I've done this is because 70 is obviously between 64 and 125. Now, how much closer to 64 is 70 than the number 125? Well, 70 is only 6 digits away from 64. And 70 is what? 30 and then 25, 55. 55, is that right? That's crazy, isn't it? 55 digits away from 125. So it's much, much, much closer to 64 than what it is 125. Now, what does this mean? What's the cube root? See, I'm still trying to say it. What's the cube root of 64, or what number times itself gets you to 64? That's the number 4. What's the cube root of 125? What number times itself gets you to 125? That's the number 5. And the cube root of 70 lies somewhere between these two. In other words, it's between what numbers, guys? Between the numbers 4 and 5. And so the cube root we're going to write of 70, the cube root of 70 is greater than, when you're looking at it this way, is greater than 4. However, it must be less than the whole number 5. And so that's how you find between which integers these lie. Just like we did with the square roots, only it's cube roots. And an easy way of remembering it is that the number that's the square root, in this case cube root, it's always going to go between, and it's always going to be greater than this one and less than this one. And so your arrows are going to be looking like that on one like this. Let's try a negative and see if that's any different. Okay, negative. Remember, it's a negative, not a positive. And so we're going to have a negative number that's closer to 0 here, and a number that's farther away from 0 as a negative over here. All right, that's the way it's going to look, because we count from greatest to least, and that's true with negatives too, even though it's going to look like it's going in the opposite direction. Okay, so what's the cube root of negative 5? Well, we don't know that. We're trying to find between which integers the cube root of negative 5 lies. And so what we're going to do that, I'd say an easy place to start would be with negative 1. Okay, let's do the cube root. Okay, I'm going to kind of draw a line to let us know that belongs up there and this one's down here. Let's do the cube root of negative 1. Okay, and then what would the next one be? Negative 2. Well, that's pretty easy. But remember, we're counting from greatest to least, and whenever you're doing that in the negative direction, you know, things kind of look backwards, but don't forget that. So the cube root of, what do we say, negative 2, all right? Or I'm sorry, we got to do perfect cubes. I'm ahead of myself right here. You'll see why here in just a minute. We have to do perfect cubes. 1 or negative 1 is a perfect cube. That works. And also negative 8 is the next one in line. Okay? And again, there's a reason. Let me show you why. Okay, so what's the cube root of negative 1? In other words, what number times itself, times itself, times itself gets you negative 1? There's only one option, guys, and that's just the number negative 1. Remember, whether it's squared, cubed, square rooted, cube rooted, it's still going to be 1, or in this case, negative 1, since it's a negative. Okay? What's the cube root of negative 8? In other words, what number times itself, times itself, times itself gets you to negative 8? What's the same thing as this example up here, but just with a negative sign? It's the number 2, except since it's negative, it's negative 2. Because negative 2 times negative 2 is a positive 4. But positive 4 times another negative 2 is negative 8. Okay, so these are the two closest. Look, the square root of negative 5 has to fit between these perfect cube roots. I'm sorry. Well, as I keep doing that this lesson, understand I'm referring to cube roots. We've had so many square roots for so long in this chapter. But obviously the cube root of negative 5 goes between negative 8 and negative 1. Now, is it closer to, well, we're not going to deal with that right now. We will later. So what we're going to do is we're just going to write in the cube root of negative 5. Cube root of negative 5. Okay. Is that going to be greater than, or is it going to be less than negative 2? It's going to be greater than negative 2. Okay. However, it's still going to be less than in value the number negative 1. And that's the way you'd write it. So an easy way to remember, whether positive or negative, that your, if the gator's eating, okay, and he's hungry, he's always eating to the right in these problems. And that way you never have to question, you know, which way do I put those signs. But it's going to go between those two numbers, 4 and 5, negative 2, and negative 1. Okay, now number 3, here's what I was trying to do on these and getting a little bit ahead of myself. We want to estimate the cube root of 17 to the nearest 10th. Estimate the cube root of 17 to the nearest 10th. Now this is just like our estimation of the square roots, except again it's a number times itself, instead of just a number times itself once. So what we're going to do is try to find some perfect cube roots, okay, one on the left side and one on the right side of that. Now 1 we already know, we've been dealing with it quite a bit here. We dealt with it as well right here, but in the negative form. We'll do it back in the positive form. But let's do 8, because we know that's a perfect cube, okay? On the left side, since we're dealing with positive numbers, we'll do the cube root of 8. And what's the next perfect cube? Now that one, by the way, what times itself gets you to 8. That's the number 2. We've established that. Well, let's just go up to the next number. If I have 3 times itself, what's 3 times 3? That's 9. What's 9 times 3? That's 27. So I can take the cube root of 27, and the reason I do those two is they're perfect cubes. And I know that the cube root of 8 is 2, and the cube root of 27 is 3, because 2 times 2 times 2 gets me to 8, and 3 times 3 times 3 gets me to 27. And look, the cube root of 17. 17 falls between 8 and 27. So I know that I'm on the right track. But what I'm doing here is not just placing them between 2 integers like I did in number 2, but what I'm doing is trying to estimate it to the nearest tenth. Now obviously if it's between these 2 numbers, which is almost perfectly so, then it's going to be not 2, meaning greater than 2, but not 3 as in less than 3. So it's going to be 2 point something to the nearest tenth. Ken, on your homework, one of those you missed, buddy, it wasn't rounded correctly. I think you rounded up to the nearest whole number when it said to do the nearest tenth. So I'm looking back over that back on the square roots. That might be a help to you in that correction. And I told Ken, guys, and I'll tell my algebra class too, but for all of you in pre-algebra, I am accepting corrections on your homework for 100% credit because of our extraordinary circumstances. So please take advantage of that, okay? And if you do, your grade will probably be great. And if you don't, it probably won't be. But I'm granting you that leniency because I know this is kind of a hard time. All right, so how far is 17 from 8? 17 is 9 places away from 8. How many places is it away from 27? 10 places. So basically, I mean, it's almost just smack dab dead in the middle. And if you're doing a decimal to the 10th place and it's right in the middle between them, well, half, going 1/2 up to the next number is going to be a 0.5. A 0.5. Now, if I wanted to take the time, I'd show you on a calculator that actually the decimal closer to it is 2.6. And again, I could demonstrate that to you. But I'm not going to take the time to do that. Remember, I told you guys, if you get within, for sure within 1, if you get within a couple of tenths in your estimation, and really the only way to finish it off is with a calculator, you know, you want to do that, I don't really care. That's fine. Go right ahead. This is pretty tough stuff that we're doing. But if you get that close, again, technically it's more 2.6 if you punch out the numbers, but I take 2.5 because that's a good guesstimate right there, and that's close enough. All right, let's move on right up here to number 4. What if I have the cube root of a ridiculously large number? How do I figure out what that is in a broken down form? Now we did this with the square root. The way we can do it is break it down into factors. I'm going to show you 2 ways to do it, just like I showed you on square roots. There's a shortcut way for easier ones, and for harder ones, there's not really any easy shortcut to it. This one I'm going to show you a shortcut on, number 4. What have we found is a small perfect cube root? Look right down here. The cube root of 27 is 3. Can I take 27 out as a factor of 2700? Certainly. So why wouldn't I do that? So here's what I'm going to do. I'm going to break this down. Remember, you can break it down into its factors. And here I need to place that a little bit better, that 3, showing the cube root. Okay. I can do it like this. Cube root of 27 times what's left over if I pull a 27 out of there. In other words, what times 27 gets me to 2700? Well, it just has 2 zeros, therefore it has to be the number 100. Okay? Has to be the number 100. Alrighty, righty, alrighty, how about you? Guys, why did I do that? Because I know already, based on the work I've been doing back here, what the cube root of 27 is. And so I can immediately simplify the cube root of 27 to 3 outside of that cube root sign. And the reason for that is 3 times 3 times 3 is 27. Therefore, I could just drop the cube root sign for the 27 and make it a 3. Now, as far as 100, is there any perfect cube of 100? Well, we do know this already. We do know this already, that 4 times 4 times 4 is 64. Okay, what about 5? 5 times 5, we've done that a time or two, times 5 is 125. Guys, that was the cube of 4, 64. The cube of 5 is 125. So is there any perfect cube of 100? No. And there's no way I can factor it into one that is. And so I'm just going to stop right there at that point. That's in simplest terms, 3 cubed root of 100. Now, if you were to punch all that in your calculator, it would give you a final answer with a decimal, but it would be counted wrong on your homework and on your test. And the reason for that is this is simplified standard form when you're dealing with the cubed root. So I don't care if you want to use a calculator to help you break it down some, but don't give me a final decimal unless it's requested to be that way, and that's okay, because normally you want to keep that cubed root symbol intact. Okay, what about this one, number 5? We have 7 times the cubed root, notice that 3 there, of 1080, okay? So here's what I want to do. I'm going to keep my 7, my cube root sign, but I'm going to break this down into some factors. I'm going to do a really easy one, kind of like up here. I can look at that and say, well, 27, because it's the first 2 numbers, and we have 2 zeros, will come right out. 27 and 100. I can do something similar right here. Since it ends in 0, okay, since it ends in 0, I know that 10, the number 10 will factor out of it, because we could count up to it in tens. Take a little while, but we could. So I'm gonna make one of the factors 10, but I also need to multiply that, the cube root, to keep it intact and mathematically correct. If I divide this by 10, guys, all I do is knock a 0 off the end. And so what other number do I have multiplied to 110 that would get me back to 1080? Not 1800 or 1800, but 1000, 0, then 80. All I have to do is drop a 0, and I have 108, okay, 108. Now, I'm just going to keep bringing these down, 7, okay, but as I do it, what I'm going to do is I'm going to break all of this. I can also put it back together, I can break it apart, I can put it back together as long as it remains multiplied by each other, okay. Here's what I'm going to do. I'm going to break these down into its prime factors, and I'll show you why in just a minute. What are the 2 prime factors of the number 10? That's what I'm trying to say. I can spit it out. Sometimes it's hard. What are the 2 prime factors of 10? And we're not using 1 and 10, and we couldn't, because 10 isn't a prime factor. It's just 5 times 2. Okay, and let's go ahead and write this cube. I know that's easy to drop off. Let's keep that on there. 5 times 2, and I've taken care of the 10. Okay. What are a couple of factors from the multiplication chart? Larger ones, but multiplication chart factors still nonetheless. What are 2 factors of 108? What those are the numbers 12 and 9. Again, I know those are larger ones on the multiplication chart, but they are nonetheless, because 12 times 9 gets me to 108. Does that make sense about all these numbers I have as products? This is all still equally, exactly the same thing. I'll show you why I'm doing it. Stay with me. I bring everything down once again because I need to break down even further what's in here. The 5 is prime, the 2 is prime. However, what is not prime is the number 12. Okay, what are my factors of 12? I want to use ones that will break down quicker. I could use 6 and 2, that would work, but I can also use 3 and 4, right? And you're eventually you're going to get to the same point, so it doesn't matter what numbers you choose as long as you keep breaking them down. 9. What are 2 prime factors of 9? 3 and 3. Okay, I'm almost there, stay with me. 7 cubed roots, that's not 7 to the 3rd power, but that's 7 times the cubed root of 5 times 2 times 3. How can I break down 4 into prime factors? Guys, 2 and 2, and then I have my 2 3's times 3 and bring those down. Okay, now here's what I need to ask myself. Kind of like with squares. With the square root, if you have 2 of the same number, then you can pull the 1 number out and cross out those 2. Because for instance, 2 times 2 and the square root of 2 times 2, which is 4, would be 2. See why you can cross them both out and just pull out a 2 over here and multiply it by your outside number, because that's being multiplied by everything that's on the inside. Well, it's similar, but with a cubed root, you have to have 3. Okay? With a cubed root, you have to have 3 numbers in common before you can just pull out that 1 number itself over here. And look, that's what I have with 2 times 2 times 2. What is 2 times 2 times 2 is 8. Well, you take the cubed root of 2 times 2 times 2, which is 8, right? And what do you have? 2. Because 2 times itself 2 more times gets you the number 2. And so I can move, because I have 3 2's underneath there, I can move that times 2, one of them, to the outside. Look, I have 3 times. So guess what I can do after crossing out all 3 of those 3's? I can move 1 3 to the outside, and here's why. 3 times 3 times 3 is 27. What's the cubed root of 27? Or what times itself 3 times gets you to 27, and that is the number 3. And so I can pull one of those 3's after crossing all 3 out to the outside. And so here's what I have. 3 times 2 times 7, okay? What's 3 times 2? That's 6. What's 6 times 7? That's 42. I'm going to write our answer up here, okay? So my outside number is 42 times the cubed root of, what is there as a number with which I can do nothing? And that is the number 5. So my answer is 42 times the cubed root of 5, and I leave it in that form. Punching your calculator is going to give you a decimal, and that's an incorrect answer. Not because technically it's incorrect, but because it's not in standard form, and it's not asking you to put it in anything other than standard form. So our solution is going to be 42 times the cubed root of 5. All right, guys. That's our lesson for the day. We'll have our test review tomorrow. I know this is, it's more challenging than what we've been doing with the square roots, and there's been enough of it there. But remember what I told you. I'm just starting with Algebra 1. Let's see, it'll be tomorrow. I'm just starting with them radicals. Okay. Now theirs is, in fairness, going to be a decent amount tougher than what your guys is. However, they haven't even had that chapter in their Algebra 1 year yet. So you have this stuff just reasonably down, guys. I'm telling you, you are superbly ahead of the game. I'm proud of you, and thanks so much for your work ethic. I know it's not easy being away from each other, but I know that you're doing what you can. I'm doing what I can, okay? But let's keep working hard together, and we're going to see a beautiful product in the end. I'll see you guys tomorrow.